it in the computer. Excellent.
Okay.
So good afternoon to you. Again, good morning to me, since it's earlier than 12 o'clock noon time. It's a great pleasure to welcome. It's a great pleasure that we continue these sessions within the framework of the COIL and research skills. Today we welcome a colleague of ours in Hellenic Mediterranean University, colleague of mine in the Hellenic Mediterranean University, director of the International Relations Office, the assistant professor Ioannis Daliakopoulos. Few words about Ioannis. He has a bachelor degree in the Department of Environmental Engineering, Technical University of Crete in Greece, a master's degree in water resources in McMaster University in Canada, and then he performed his PhD in the Technical University of Crete in the Department of Environmental Engineering. The research skills of Ioannis, among others, are automation and sensor, remote sensing, computational decision support tools. However, Yannis also is very active as a researcher, but also as a manager of research projects at the same time. So I think that this gives, a lot of credibility on the talk and that he will present and will discuss today with us, how to craft news from scientific research. It's something very, very important for your reputation, for your, I will say, personal performance, if I intercept well, the title, and for your promotion and professional development. So, Yannis, thank you very much on behalf of COIL in the research skills, on behalf of the Impact Project. The floor is yours. Again, thank you.
Thank you, Kostas. Thank you for, first of all, thank you for inviting me in this COIL, and then for introducing. I will speak today about how to craft news from scientific research, assuming that during this COIL there has been a lot of information about how to structure your publication, how to publish it, and how to put it in journals. Let me share my presentation. You should see it on your screen now. Yeah?
Yes, Yannis, excellent.
Okay, thank you very much. All right, so let's see what we will talk about. First of all, we will talk about communication basics, the key principles of writing to non-specialists, to the non-specialist crowd, understanding the audience, how the media finds and tells the stories, and how to reach different audiences with different angles, and also to avoid some common pitfalls. Now, the central thing about communicating the research, your research, is that thinking about your goals. Finally, what do you want to achieve, to identify your target audiences, and how to best reach them. Okay, so there is this key set of questions you have to ask: who, what, how, when, and where. Okay, so who means who delivers the message, first of all. Is it going to be you? Is it going to be somebody above you? Is it going to be the department of your school that manages communication? Is it going to be a student of yours who is going to deliver this message? Then who is the target audience? Okay, and this is quite important, and we will see more about that. What part of the information you want to transmit? Do you want to transmit everything you wrote in the paper? Do you want to transmit a certain part? Do you think something is more important than the rest? Okay, how? So what type of language you will use to reach this target audience? When it is more timely, when it is more likely for the people to listen? Okay, do you want to wait for a couple of months, or do you want to do it tomorrow morning? And what platform should you choose? Should you go to Facebook? Should you go to X? Should you go to the local newspaper? Should you go to your blog, national press, etc.? Okay, so there is some key questions that you have to ask before you start doing this dissemination. So, okay, just to start the conversation, and to speak about audience. Let's try this Mentimeter thing and see if it works. And I would like very much from you to know where you come from, where are you joining from. I don't know if you can see this map. Please use your mobile phones. Oh, should work right now. Please use your mobile phones to scan this QR tag. I will give you a couple of minutes, I guess, to get into the mood. Okay, and just once you are there, let me know if you are, if anybody has problems. Okay, I see already Latin America showing up. Very nice. Okay, you can also draw on the map. Just put a pin where you're joining from. Very nice. There's one out of the map. I will give the rest some more time because, okay, the reason I'm doing this is sort of an icebreaker because I will have more questions using the Mentimeter. So test it out, see if your mobile device can scan the QR tag and you can provide some answers. Okay, so we have mostly Europe, one from Africa, one from the ocean. I don't know what is there. Some from Latin America. 11 participants. Come on, people. You can do it. You're more. Okay. So let's go to the main question. The main question is, who is your target audience? Okay, give me some ideas. There is still a line on my screen, and I don't know if it's from you or me.
Ioannis, since you are a host, there are some people waiting in the waiting room. Okay, sorry, I didn't get that because right now on my screen I can only see. Probably I can place myself as a co-host in order for the time that I will be with you. Yeah, the problem is that I only see right now your cameras, and I don't see a chat box or anything about participants. If you go to the participants, yeah, you're right. Okay, sorry. Okay, this should work a bit better. Excellent. So, okay, please go back to there, to this Menti. What I'm asking is not where you're from this time. What I'm asking is what your knowledge level is, what the target audience knowledge level is. Who do you think your target audience is? What do you think they know? I see on my other screen that I have some updates. Wait. Okay. So knowledge academics, undergraduate, beginners, students, not Uganda. Okay. Researchers, students, professionals, academics again, and so on. General public, 1. Postgraduate,
Okay. Beginners. Let's move forward. Okay, so who is your target audience? So let's say, who could be your target audience? You have your message. You have the so what? So what happened with your message? I mean, who cares? Who could care about your message? It could be policymakers, right? Okay, so the policymakers care about if this message you are transmitting supports their position, supports the position of their voters, supports the legislation that they're trying to pass, okay, will help them out in an argument when they go to the parliament, okay. This is what, or any other decision-making body. This is what the policymaker cares about. This is why they will read your article, okay. And I'm not talking, again, let me go a step back. I'm not talking about your paper. I'm talking about an article in the press. I'm talking about taking your paper from manuscript, from publication, to the general audience. Okay, so back to the previous question, this is a more general audience that we are reaching. We're not reaching now the scientists. Okay, so another audience is the managers. Okay, so the managers care about specific problems. How does this solve a problem that I have in production, in my daily work, with my employees, okay, with the finances? Can I sell it? There are NGOs, they have agendas, they want to promote environment, they want to promote animal welfare, they want to promote many things. Does this fit their agenda? Will they use it somehow? So people, these kind of people, they want to accumulate arguments. Oh, you know what? This scientific work wrote this. I cannot read it from the journals. I read it from the press or a blog or science news. Okay, so they want this part. And then there are scientists, us, okay, does this relate to my work? The scientists can also read it from the journal, but they also read more general stuff. We also read the papers, the science sections in blogs, etc. So if it's relevant to our work, we like it. We will be drawn in, okay? And if it's innovative, groundbreaking, this is also an aspect that you have to catch. There is media. So you might write a blog post and the local newspaper or the local media station, radio station, TV station, will catch it, or from a press release of university, will catch it and say, okay, is it news for us? Will it sell? The media has a specific way of thinking. The currency of the media is the time of the people who read it. So will the people who read it, my audience, invest the time in reading it? That's what matters to them the most. And then there's the general public. That's it. Why should I care? Okay, why should I care about this information? These six dimensions here are possible audiences. Now, in this lecture, we care about media and the public. Why is it news? Why will it sell? Why it will matter to one chain below that? Why will it matter to the public, okay? So in order to communicate your research effectively to this audience, to the media and the public, you need to understand them. You need to understand them very, very well in order to be effective, to pass the message, okay? So you need to think about three elements in the beginning. What knowledge do they have? What pressures do they have? What problems every day? And what kind of questions they will ask? Okay, so another Menti here. What knowledge level this time, not what your audience is, okay? We specified that our audience is the wider public. Okay, what do you think the average Joe knows? Okay, so what is the knowledge level of the non-specialists? Are they primary school level? Will it start? Primary school level, high school level, graduate, okay, or postgraduate? Scan the QR code with your phone, please, and give it an answer. Okay, what do you think? This, of course, could be a bit different in every country, yeah? Of course. Okay, mostly high school level. I get here postgraduate level, second. Primary school is third right now. We have 12 people active on average. Okay, so yeah, you have to think back that most of the people, typically, they finish high school, okay, and they go to work. Typically, people don't earn master's degrees. Maybe in some countries there is a much more degree, let's say, inflation, and you might have people out of university more, okay? But typically, the average Joe out there has finished high school, has finished school. And then you have to think back, when you finished school, what was your level of knowledge in terms of your science? So did you know a lot of biology? Did you know a lot of physics? Did you know a lot of chemistry? Okay, we probably know from these years, when we were 18, we probably know enough to solve an equation, and most of the people out of high school might have forgotten this. We probably might have known how to solve a simple chemical reaction, but everybody forgot about it, right? For sure, I even though I'm in the university, most of the things there in chemistry I forgot. Okay, about biology, you might remember what the cell is, but not so much. Maybe DNA says something to you, but you won't know about mitosis. Okay, so the level of knowledge of the people you are addressing needs to stay at this. Everything that's more complicated becomes an issue. And there is a very nice talk that I quote later in my in the last pages of this presentation from the School of Chicago. Okay, if at this level that we are right now, we are no longer writing stuff so that our professor can correct it. That's finishing after graduate school, let's say. Okay, so if you have graduated, you start writing stuff for people who pay to read them, okay? And the currency, as I said, for the average Joe, for the common people, is time. They will spend their time to read your work. And the moment that this becomes boring, the moment that this becomes too difficult to understand, the moment they have to read it twice, I mean, you don't expect somebody to read something and then on the side open a dictionary or Google stuff. That's maybe we are doing this, but the average Joe wants to read something and get done with it, understand the information, get the info, know how to use it in his daily work, and go to the next. So this is how we deal with information on that level, okay? So the moment that somebody stops and rereads, then he says, okay, I'm bored. So your message can be removed. So, okay, what pressures these people that they are, we said, high school level, correct? High school level. What pressures do they have, these non-specialists? What are they under? Can you give me some ideas of what they have what they have in their daily life? This is also a word cloud. So if you can give a couple of phrases there, that would be nice to start a discussion. Time, very nice. Yes, money. I would stay there. That's it. Work, of course.
Ioannis, can I mention something on this?
Absolutely.
Thank you. Thank you very much. I would say that, from my perspective and for my, small experience, is like the lowest, the academical level of the stakeholders that you would like to transmit your scientific message, the hardest your work happens. So these are going in a reverse direction. So the lowest the academic level, the hardest for someone to transmit an academic or a political, let's say, statement to them in order to understand becomes harder and harder. Not because the people, they don't know, but because they have this, let's say, language, terminology gap. I still insist that the hardest presentations to make, the hardest publications to make are those ones that they are under the popular science, let's say, discipline. This is, what I would like to say.
Costa, I think the hardest is for kids. The hardest is to go to elementary school and explain to people to individuals that don't have prior knowledge about anything, maybe cartoons. Nowadays, of course, more than before, but to explain to people who don't have priors about your science. And this means, I think there was a quote from Feynman, and maybe I think it was in this presentation round as well, that in order to reach that level that you say, you have to understand very well what you're doing. You have to have a very good understanding of your science to be able to break it down in coins. Okay,
correct.
This is
very correct.
It's a very crucial issue. Okay, so what do we have here? We have environment, financial, interest, limited vocabulary. No, I mean pressures in terms of what, for me, time and money comes up in every presentation that I make. That's what do you want? I want money. What are you missing? I'm missing time. This is for everybody. It's so the people that the message reaches, they don't have time. Okay, so they want to learn about what your information is very quickly, not in a book. Otherwise, they would buy a book. Okay, and the best way to reach them is to tell them how they will make money out of this. This is the top. This is the top. It's not always possible, and it's not always relevant, of course. Okay, but the top is to say, guys, Bitcoin, you will make money in 1 minute. Perfect. They want to learn about it. Okay, this is not always feasible. There are other aspects, of course, everyday life issues. Excellent. How this will make your everyday life easier. Work, how this will make your work easier, how is it relevant to your work, etc. Yes. Okay, and what questions might not specialists ask? Okay, what are they asking? This is a very general, a very broad, sorry for this, very broad question. Okay, and it's also related to the other one. So if you're pressured by financial issues, how do I make money? You can try the Menti here just to have a conversation. I don't see a lot of action here, but yes. So what? So why do I care? Exactly. This is the biggest question. So what? This is the biggest question, and I think the scientists also ask it all the time. So what? If you are reviewing a manuscript, you already asked this from the beginning. Why do I care about your research? This is, and the public is an even worse critic, let's say, harsh critic, because it's their time. So what? Why do I care? How will it help me? Exactly. How do I save time? How do I make money, etc. Okay, so to wrap it up, the audience, it has no specialist knowledge, okay, very basic knowledge in your area. They are very, very busy. Sorry. And the first question that comes in their mind is, what is this about? Why should I care? What are you selling me? And why should I give you my time? Okay. And this part is very important because out of your research that is very, very analytic and covers many things, and many journals will ask you not just to present the results, but also to present the background information and, let's say, suck up on the rest of the academics and put them also in references and say what others have done in the field, etc., etc. So it's, you write all this information and then you discuss all this information in your discussion section. You are very, very clear in your methodology because you want other people to review it and say, okay, yes, you did it the right way. Okay, but now what's important is that you need to leave out many aspects of this, and you might feel very bad about this because you say, I did all this effort. I did all this effort, and people should know that I did all this effort. Okay, but now this is not the time to brag about how your Microsoft code works, and you cannot turn the people into experts. That's not your work here. The problem is not to educate everybody, because you cannot. This is not the forum to do it. Here, the forum is to inform the people only about why it matters, why your work matters, okay? And yeah, of course, everybody's an expert, as this illustration says here, okay? So in the 80s, the recognition came to the leading scientists, and now today, Miss Mary or Karen from Facebook, she knows everything because she has all this information in front of her, and she can pretend, especially on X or Twitter, to be an expert on everything. Okay, what you need is not to educate her and change her mind and put more information in her plate about, exactly why you're right. You need to say what you did mattered more and highlight this difference that you made, okay? So let's start with how to structure this, this work in order to achieve it. Okay, I borrow this from the work, from the presentations of Monica and from the book that she shared with me. It's from Simmel on the science of writing. And this is the typical, let's say, structure of the paper as we know it. You might know it in a different way, a bit modified, but generally there is an opening, what we call the introduction. This introduction ends to a challenge. Okay, so I typically want to say to my students that when they write a paper, the first part should be grant heading, everybody will die. We will die because we are not doing this the way we should. Okay, very big headline. So introduction, we narrow down to the particular challenge that this paper addresses, and then we go into materials and methods, and then we go into results, and then we go into discussion and conclusion, and eventually we say, what the outcome of this work is. And this is the way we structure it, because this is the way we think, and this is the way we structure it because the people that are reading us in the audience of scientists, this is the way they perceive information, and they know where the real estate, let's say, of the paper is. And if they want to check your methods, they will go to the method section, and there in the method section, they don't expect anything else but methods. Don't give me results there, don't give me your case study, don't give me anything, just the methods. I want to replicate it, I go there. Okay, if they want to go to the results, they go to the specific sections, etc., etc. We know how this works. Okay, this is very concrete to scientists. Okay, so this, you can generalize, let's say, you can generalize and say that the way the scientists write are on the left of this image, there is a pyramid, okay? And you say a few things on background, you say some things on methods, then you address results and conclusions. And this is how we work. This is how we structure the work. Now, how journalists work is exactly the opposite, okay? They present first the results and key points. What the big headline is always, they measured this. They concluded in that. Because the headline is what will draw people in. So the most important thing is not scientists in the University of XYZ did this. Nobody cares. Who cares? Who found it? What did they find? They made this discovery. Okay? So journalists always start with a highlight, with the results, with the conclusion of your work. And then they start to drill down on the details. Okay? Why they did it, how they did it, and all your methods, and maybe they leave something out, and maybe they use one figure that's really important or really easy to understand, okay? And they drill down to decreasing significance and increasing detail up to the real estate they have. If the author of this, the journalist in this article, or you as a writer, you have 3 pages, you can drill down to as much details and implications and so on as you want. But if you have 1 paragraph, you fill in this 1 paragraph with the most important points. Otherwise, there's no point, because nobody will reach page 6 to find out what happened. The scientists are the opposite. We read the abstract, we expect the conclusions to be in the last page. We go to the last page to see what went on. So the way journalist structures is the opposite. We will call this an inverted, let's say, pyramid, okay? So this inverted pyramid has reduced importance as you go down and increase detail. And we call the first part the lead, okay? You might hear it lead, you might hear it hook, because it's like the hook that catches the fish. And the lead answers the questions who, what, when, where, why. And then you give more details, you expand on the facts, okay? You might have some quotes from the scientists. You might want to drill down on how they made it, on the methods, okay? One might want to give more background. You might want to give related facts, speak about who funded them. Okay, this is not significant anymore. We go to reduce significance, okay? So let's see some good practices on this.
Ioannis, may I make a comment here?
Absolutely.
This is what we lack. I can link, the previous presentation with your presentation. It's not only that we need to train less staff, because I thought that, they should have these qualifications, but anyhow, students, not on how to communicate their results, scientific results, how to make a presentation, how to write a paper, but also I think that we should train them how to become a journalist. Because in order to sell, in order to attract sometimes, funding, you need to operate not as a scientist, but as a journalist. So I think that both of the trainings will be included in our curricula in due time. Thank you.
Yes, of course, I agree that one part of communicating is that, and it depends. It really depends what kind of students you want to produce eventually. What kind of skills do you want them to have? It's important to understand the science. It's important to know how to write a paper. It's also important to know how to communicate. And for me, it's important because you learn how to read also both the papers, okay, and you learn how to read the news, because you will see later on that sometimes the news are easy to pick out what is good and what is bad, what is good practices and what is bad practices. Not everybody follows these rules. So if your students understand this, they also can become themselves more professional or more ethical, let's say, okay, in all extents.
To add something on this, Ioannis, before 2 years that I was in Brussels in a meeting, one of the of the European officers told me, Kostas, do you read Sunday newspapers? I said yes. And he told me, the best ideas are coming from the Sunday newspapers. So I would like to support what did you say, that the best ideas, why best ideas, probably are not so innovative, but they are related to what the society needs, what the market needs, or sometimes how the technology should be moved. So reading Sunday newspaper, reading journals like Economist, like Time, like, other kind of things that they have, all over, it is an inspirational. It will help you to understand a lot of things regarding the research and how the research is moving of any topic. Thank you.
Yes, and okay, you mentioned Time, Newsweek, okay, the Sunday newspapers indeed, and I will add something more. Okay, I mentioned this: scientists go from background to methods to results and conclusions, and then journalists the opposite way. There is one exception that I forgot to mention. There is one type of journals that also uses the inverted pyramid. Does it ring a bell to anybody? You can write on the chat or speak up. There is a type of journal that the first thing they say is conclusions. Does it ring a bell? Everybody reads it, or everybody wants to write there.
Nature or science, they have specific kind of sections, and
exactly.
Articles.
They have a specific format. Okay, if these generalist journals, Science, Nature, and other outlets such as this, they have a specific format. The abstract has a specific format. Goes to, we found this. Here we show this. Okay, this is very typical. And then, if you have noticed this, I'm sure you have noticed this, the methods, we don't care about them. They are in the bottom. Who cares? Here in this journal, to get accepted, we already know that you did it the right way. It has already been thoroughly reviewed by many, many people. And we don't need to get real estate from the journal, from what people will read. This is at the bottom. Okay, so we already do it. Of course, this is also very focused science indeed. And Kostas, you are right. Like if you go to specific, not popular, but high circulation newspapers, not just popular, high circulation newspapers where they have specific areas for science. This is where the most important things come from, because there they have specific editors where information, the journalists fight for their real estate, and then they pick out the most important things and produce them to the public. Okay, so let's give a short example. Okay, so there is this article from Cell. Okay, and it speaks about melatonin, Kostas, so pay attention. So it says that the title is Melatonin Signaling Controls Circadian Swimming Behavior in Marine Zooplankton. And I know that some will Google it, so I've already done it for you. So circadian is a function of the living organism that happens every 24 hours, even if you don't have light. Okay, so it's a sinusoidal, let's say, function. When it's day, you do this process. When it's night, you do this process. It's like in plants and the release of oxygen or the intake of CO2. Okay, so circadian, it says melatonin signal controls circadian swimming behavior in marine zooplankton. Okay, so if you go into this publication, the first thing you see is it has very extremely complicated, even for us, I think, figures. This is one of the simplest ones. Okay, and if you go into the summary, it says melatonin, the hormone for darkness, is the key regulator of vertebrate circadian physiology and behavior, despite its ubiquitous presence in metazoa, so in some marine zooplankton. The function of melatonin signaling outside vertebrates is poorly understood. Here we investigate the effect on melatonin signaling on circadian swimming behavior in zooplankton model. So it speaks also about a model, it's not actual zooplankton. So it also mentions specific species of this zooplankton. And then they say we find that melatonin is produced in brain photoreceptors with a vertebrate type. And then it becomes very complicated. It goes into details and what it regulates and so on and so forth. And eventually they figured out that this melatonin regulates also how zooplankton acts. Okay? How this went to the press? Okay, so from the University of the Scientists, not the scientists themselves, they issue a press release now. Okay? So look at the title. How plankton gets jet lagged. Okay? So from melatonin signaling controls circadian swimming, what they get out is, okay, melatonin actually controls sleeping patterns, and we figured out that it can confuse, let's say, plankton. And the key word is jet lag. Why is jet lag? Because when the reader sees it, the reader can relate. Okay? So, an open question here. What do you think the implications of this could be? Okay, why would people care? You can open microphones and speak. Why would you care if plankton gets jet lagged and melatonin can solve it or plays a role?
The only thing that I know, and before I will move, I have to go to the classroom to teach. Plankton is very important for the oil production. So plankton is the resource of oil, petroleum. So probably this will have an impact regarding jet lag. Probably has to do something with the quality of the oil that then starts from the plankton. I have no, this is the only thing that comes to my mind if this has an impact. But now you are talking about the jet lag, probably you are talking about the humans, one of the ocean again. All right, so it's very related with the oil because everything starts from plankton that exists. Of course, plankton exists only in the ocean. In order to move on, but this comes to my mind, just to come.
It could be I mean, yes, okay. Not everybody knows this, of course. Okay, you have to think about as I said, the level of knowledge that you have when you finish high school. Okay, and I don't think this is typical. Okay, for me this is a bit a long shot. However, okay, it could be. It depends where the hook for you is. If you get hooked from plankton because of oil, that's still fine. But typically jet lag, I mean, everybody can get it.
Yeah.
So people will understand. Okay, yeah, this is talking about jet lag. So maybe they can find a medication for jet lag. Oh, let's see what they found. Because here it's let's say, modeling study on something that could mean something for humans as well. Maybe they make melatonin pills tomorrow. Okay, so this could have an implication for your day life.
However, Giannis, yeah, this is true. But thinking about bioelectronics, so sometimes regarding Parkinson, you develop something that it has the opposite, direction of what Parkinson creates. So stabilize. Mm-hmm. So probably here, the plankton should, provide, the opposite jet lag. Because if you move from east to the west, or from west to the east, the impact of
you know it.
Yeah. So probably, yeah, I agree with you. It has, but yes, thank you.
Okay, so bottom line is that this story, this catchphrase at the beginning, one of the world's largest migration is probably driven by a hormone, it says, that governs our sleep patterns. Okay, so this hormone is so important that it moves the population of a full species. Okay, so maybe it also plays a role for humans as well. Okay, this is the message that they're trying to, the hook they're giving. Okay, this is for a very small organism, but look at the impact on this small organism. Maybe it's important for humans. And this is, the jet lag was such a catchy phrase that this picked up instantly. As I said, this is a blog in the university itself. Of course, okay, in this case, it was made by a professional in that university, not the authors. And this is also a good idea, Kostas, if you're still there, that special, people with special writing skills, it could be the students of tomorrow, when they understand what's going on, can have this job position to take research. Maybe they don't understand 100% of what's going on in this research, but they understand what's catchy in that research. Okay, so it completely picked up. You see other titles that are similar. Plankton gets jet lag too, with a question mark, without a question mark. In Norway, melatonin in the water beginnings of sleep. Okay, so this title on its own made a huge impact and led people to read, and the journals, the science communicators, the science communication journalists to propagate this information further. Okay, so yeah, I think we discussed this already. I was going to put forward a Mandy here saying, okay, we got it. Plankton gets jet lag. Why do we care? But I think we already analyzed it a bit. We care because this can have implications for the human species as well. Yeah? You could push the ball further and say, this regulates your sleep patterns, or this regulates other habits in your day, or this regulates behavior. So if we understand what's going with the plankton, which is a model, okay, I will see further on, model is not a very good word to use with the average Joe, but if we understand what's going on with melatonin and plankton as a model, then we might start understanding how this hormone affects humans as well. Okay, so why should people care? To wrap up, okay? We generally care about the things that affect us, that relate to us. We want to see a mirror of ourselves there. How do I fit in this puzzle? Okay, it needs to fit our everyday life. We might, another option is to see how it affects the people around us. Okay, not just us, but the world we're moving in, how it affects the economy, how it affects the environment, how it affects, but something that we can relate to, something that we care about. And to give a better understanding of how the world works around us. Okay, this is something that can be catchy for a lot of people. Now, there is one more section I will discuss here about choosing the vocabulary bit. This is also important. As I said, we should understand the audience in the sense that they want to get the information, and if you overcomplicate things, then it becomes more difficult to pass this information across. They will start to reread it and say, what do they mean? And why do these scientists use all this jargon? Okay, so if you have jargon, how to deal with it is simplified. If phytoplankton you think is a word that was never in the textbooks of high school, then you can get rid of it. You can either get rid of it or you can explain it. And another important thing is that when you're explaining these articles that are meant for laymen, the way of explaining is that you first say it in a simple phrase, microscopic floating algae, comma, otherwise called phytoplankton. Okay, because typically we are used to the opposite. Phytoplankton, otherwise called this. No, they simplify and then give, if you want to be right, this is called by scientists, this expression. Then the individual reading it understands the first phrase very well, and then also gets the jargon. Okay, this is how you call it, fine. If they want to skip it, they can skip it without missing the content. You can put this in a parenthesis, let's say, yeah? Or you can put it between commas. This is not the important information. You don't want to educate them, to tell them, okay, this is called phytoplankton, and tomorrow, this time, come back, I will check if you know it. They don't care. So microscopic floating algae will do the work as well as phytoplankton. So open thesaurus on the internet and find other words for jargon that you use typically in science, and it's between us, it's fine to use, but nobody else understands. So as I say here, yeah, first you define the technical term, okay, and give a reverse definition. So I quote here, microscopic floating algae known as phytoplankton. I mean, this is the way to go when you are explaining something, okay? Now, there are other issues here when you're using this jargon, this scientific information, okay? There is words that for other people mean other things. And this is very typical word is a model, okay? The model can be a mouse because it's a model for a biology experiment, okay? Instead of using humans, they're using live animal, and they're called models, okay? Depending on the functions, it could be worms, it could be nematodes, anything. So for these papers, it's a model. If you transfer this word to the layman can understand point 3, a fashion model, okay? A model for engineers is a computational simulation. So for different people, these words that are jargon mean different things. And also I will go back to this Chicago talk. Okay, when you write, and I think this has been also in the presentations in this COIL, when you write your paper, you select the journal. Okay, this is ideal. First, you select the journal. Why you select the journal, especially if it's a specialist journal, not a generalist. So if you're not writing for Nature and you're going to a specialist journal, then it's as if you go to a community of experts in a closed club of experts. And if you don't use this jargon, they will kick you out. If you don't use the word model the way they do it, they will look at you funny and say, what do you mean? This is not called like this. So the first review you will get will be a reject because you're using the terms wrong, okay? There is right and wrong, and there is a very specific way in that you should be using this jargon. Here, it's almost the opposite, no jargon. Anything that you say that's beyond the level of, as we say, high school, will be misunderstood. Okay, and people will confuse what you're trying to say. Nobody will, not nobody, but there will be a small group of people understanding, but many of the readers will scratch their head and say, what's going on? So avoid this type of unintentional misunderstandings. Okay, also, we are used to writing research in passive voice. An eruption was observed, okay? But here, we need to know who did it. It was a scientist. It was an instrument. It was what did it. So typically in such types of articles, we use active voice. So it's not an eruption was observed. It was geologists who saw something happening, who recorded it, etc. So always choose active over passive voice. Always use more simple words. Okay, so rather than saying indicate or depicting or visualizing, use the more simple counterparts, show, do, see, okay, not initially, not conclusively, not sufficiently, not significantly, because significantly, we know what it means in science, but they don't know what it means in the daily newspaper, okay? When you say significantly in science, somebody expects a p-value, Okay, when you say significantly in the papers, in the daily press, you mean that it made an impact. Okay, you don't mean that there is a statistical significance. So these are quite important. Okay. Also, simplify other long-form phrases which are not necessary. Okay, we are used in journals, although for me it's also redundant. Like whenever I review something or whenever I write something, I also use this approach that using more, Baroque, let's say, style writing is completely unnecessary and it completely burdens a document without any significance. So I make a very big point of never ever using in order to. I use to. Okay. It's not, it doesn't add anything to the message you're trying to convey. And I think this is true for even for science. Okay. So keep it simple, about, rather than with regard to, by means of. Nobody knows what by means means. By, simply. Adequate number, it's just enough. Okay. So go to more simplified ways of communicating. Okay, now another point is that much of the information, as we said, that we want to convey to our readers, they cannot really relate. So, okay, you go from your big headline, from what we call the hook, you go from this hook to more information at some point in the document, in the text. You want to present some figures, some numbers, okay? So we made this treatment in our plants, and our plants, instead of producing 1 kilo per hectare, they produce 2 kilos per hectare. It's very typical that the average Joe out there doesn't know what the typical value of production is. So they don't know if 1 kilo per hectare is a lot. They don't know if 2 is a lot. They cannot relate to these values. Okay, this example here gives an even more, important aspect, that once you talk about very big numbers, let's say astronomy numbers, okay, if you talk about the distance of Earth from the center of the galaxy, I don't know, or even from the sun, the average Joe cannot perceive this distance because they have not seen this distance. Okay, when I try to explain to my daughter, okay, what the distance of Earth from the sun is, I always try to put it in things that are tangible. Okay, so you all know this analogy of this having the basketball and the orange as an analogy of having, for example, the sun and Earth, and pretty much figuring out the distance. Okay, so this is the way you should be approaching all this information. So here it says, okay, so this, in a scientific paper, they established how round an electron is. Okay, and it says, okay, it's very round, so they could have this figure that is 0 point so many zeros, 1 centimeter. They could also have it in scientific terms, in science notation. So with an exponent, okay? But this would be even worse because nobody knows what this is. I mean, you won't have a logarithm in a daily paper, okay? So then they give an example. They say, okay, the experiment which spanned over a decade suggests that the electron differs from being perfectly round. So there are some anomalies, but let's see how many these anomalies are, by less than 0.x zeros 1 centimeter. This means that if the electron was magnified in the size of the solar system, it could still appear spherical. So you could make it as big as the solar system and you wouldn't see any flat corners, okay? to within the width of the human hair. Okay, now I understand. You're speaking about something huge, obviously, and the fraction of error, let's say, there is minuscule. Okay, now I understand what you're talking about. So these types of analogies, and I think now that I'm speaking about it, this will also be a written assignment or some kind of quiz. Okay, these types of analogies are very important because they make the layman understand what you're talking about. Similarly, in other experiments, as I said, give the normal result, the normal ratio. If you say, okay, I produced this much tomatoes per hectare, or this treatment killed this many insects, or I built something with my 3D printer that's extremely strong, bring an analogy. It's stronger than steel. Okay, it's more than the average global average. It's more than, okay, so bring some kind of context there so that the person who reads it, first of all, understands what you're talking about, and then can understand why you're excited, which is very important because we are always excited about our research, but we want to convey this excitement, but the audience on the other side does not understand what is going on and why you're so excited. So give this analogy and try to highlight it as much as possible. But okay, this is not something trivial. This is very important because look at this difference that we make. Okay. And how do you find the great analogies? First, you identify what you want to explain. Make an abstraction, so think about it. What the essence is, okay? What is it, what you do? Find a parallel, something that on the everyday somebody can relate. Oh yeah, I know the shape of an orange. I know the shape of a lemon. I know how much a tomato weighs because I've seen it before. I know how thin my hair are. Okay, something analogous that you do in the everyday life. And then you write it up, you test it. Does it work? Does it sound funny? Does it make sense? Or can I do something else? Okay, you can always take examples. I don't know. You can always ask ChatGPT if it understands what you're talking about. For sure, there will be some answers. Although I think ChatGPT is sometimes very polite. Or you can prompt engineer and say, be rough on me. Okay, so let's go in a different subject. Are there questions so far? Because we are past 1 hour and I'm not giving you some breaths, I guess. Are there any questions? Do you want to discuss something that was not clear? No. Okay. So let's go a step further to understand what the journalist does. Okay, because the cases where we are able to directly reach the newspaper are not so many. Typically, for me, the way I've published in the press, there are two ways. One is that there is a press release, and then this press release, where it's mostly written by me, is caught up by the press, and then somebody calls me up and says, okay, yeah, that's sounded important. Explain it to me. Okay, and the journalist writes it. The other is that in some cases, you have the opportunity to write the actual piece in the press, but the second is not very typical. Okay, so typically, somebody will filter it out. Somebody will see it from the press release. So you have to write the press release quite well. Okay, so that it draws the interest of the journalist. They pick up the phone or they send you an email and say, okay, you know what, this sounds very interesting. And you know what, if this happens once, then as you saw in the previous example where, one newspaper caught it or one science news outlet caught it, then it propagates because the news outlets will see the competition, say, okay, yeah, easy work. They did the first part. Let's also augment this. So the key issue, one key issue is to understand what the journalist wants, okay? So what the journalist wants is, what they do is that they collect, analyze, and verify what's going on, and then they present it to the public. So you might have somebody in your circle that is a journalist, and you speak to him every day, okay? But at the end of the day, he's not loyal to you in this sense, so he's not going to present to the public everything you serve them, because otherwise they will lose their audience. So for their first loyalty is to the audience. They want to single out things that make the newspaper sell, let's say, yeah? Make the outlet sell. So this is a quote from Roger Highfield, who is quite important in the science news communication. And he says, many journalists like you to think that we are seeking the truth, okay? But we are not. But most journalists, what they do is that they look for gossip. They're curious gossips who like to show off by sharing hot news with a big audience. So what's important for the journalist is to go out there and say, oh yes, I have this great thing to sell you. It's hot cake, it sells, hot bread. So he says, each day I search through dense scientific jargon. So he looks maybe through papers that make it to Nature, where the important things are, maybe to press releases in university that make it to, this outlet headlines, and then he filters them out. So I search through dense scientific jargon and enter releases posted on the World Wide Web to find news of interest to my readers. Underline, not to educate. Again, okay, he doesn't want to make people smarter or more knowledgeable. Okay, they want to sell the news. Okay, this is the most important thing for them. And so this is also a very big, let's say, ethical question for me. Every time that I tell you, I answer the phone and there's a journalist on the other side and says, you know what, we read this, explain it to us. For me, I typically request that before they put this out, they send it to me, which doesn't happen very often, okay? Because they know that they need to quickly take it out as much as they understood, and this is what the news. So you have to really take care about what you convey to the journalists as well. The best thing then is to write it, not to say it over the phone. You write the statement, and then hopefully they will understand. If there's a misunderstanding, you go back to the first document and say, okay, I didn't say this. This is what I wrote. So it's quite important to know how to structure this text yourself so they know how to read it, okay? And of course, if you are very good at it, you can write it on your own. So journalists find stories from the press, from press releases, from conferences, from blogs, from visits, from current news, from gossips. They might also read Science and Nature, generalist journals. And they pitch the stories to the editor. Okay, so imagine a journalist team that competes for real estate in a journal or a blog. Okay, that's very specific. If it's let's say, a blog that's for environmental, has environmental aspects, they still compete for the first page of the blog where you have all the images. Okay, so the editor reads this, and the stories compete for this space. Okay, and then they compete for the attention of the audience, and hopefully they will sell more ads. That's what the editor is doing. Okay, so now when you're going to write this press release from your journal, you need to convey what this is about. You need to underline, to make the journalist clearly see why this is news. So you have to serve it. That's why all this introduction, let's say, that I made. Okay, make their work easy. As in the paper, you make the work of the editor easy by highlighting in your abstract and your format and your style and your structure you make it easy for him and not difficult, because if you start making it difficult for the editor, the reviewers, and so on, they will say, okay, don't bother, go to the next. Okay? So you make it easy for them. You say why this is what this is about, why it is news, why it will matter to the audience. Okay? Check if there is an embargo period for your paper, if you're not supposed to say it yet. Okay? And otherwise, provide contact details for researchers and an invitation to contact you. So you write the press release, say for more information, contact Ioannis Daliakopoulos at this email, reach me at this number, somebody will pick it up if it's quite well written and very important for them. So what makes the news is that it's timely. Okay, we had this conference last year, and now we're making a press release. Nobody cares. Okay, so it has to be timely. If it's something that happened last month, nobody will care. But if there is a meeting of scientists, a quite big meeting of scientists that happened yesterday, it might even make it in the headlines because new news today. So, okay, huge meeting of scientists in Iraklio took place yesterday. Okay, quite important. This is why you have all this crowd in the city. This is why I cannot find a parking spot today, because scientists blocked the entire center. Excellent. This makes news. Okay, so timeliness, impact. It affects you. It affects a large number of people. So the more global your science is, or it doesn't have to be global, it could be local, but can have global implications. So you could be working on a model, let's say, of why something happens at planetary scale, or why something happens at species scale. Okay, find a way to highlight it. You already found a way to highlight this to your editor to make it to a significant impact journal. Highlight this to the audience as well, to the average Joe as well. Okay, we measured erosion in Crete to be these many tons per hectare. Who cares? Your productivity will go down by 30%. Oh, this is important. Okay, so it affects a large number of people. Proximity, it happened next to me. Okay, so if this meeting of scientists that I mentioned, nobody cares about typically, but if it happened in Hawaii, nobody will care in Greece. But if, as I said, this happened downtown Iraklio and nobody could park, okay, this is local news. Okay, if the community of farmers did a specific thing in the area, this affects their neighbors. It's like they want to hear this at the coffee shop. If there is a disaster happening at the other side of the planet, okay, even if a lot of people got injured or hurt, it doesn't affect us so much. We read the headlines, we don't go further. But if it's next to us, next door, everybody gets panicked because, okay, it could have been me. So this will make much larger news. It needs to be close to you to feel the impact. It might be something surprising. So you did not expect this. Okay, look, melatonin plays a role. Nobody knew. We all thought that this was the way things happen. Okay, it says here, man bites dog. This is a story. Okay, if it's the way things typically happen, it's not a story. So promote, as I say later, a narrative where things get out of the blue very exciting. Okay, and prominence, a story that affects somebody well-known or an institution of very high interest. So the government moves in this direction. Okay, everybody knows this Max Planck, let's say, so Max Planck did this. Okay, everybody will start. Okay, well, why did they do it? Okay, so big institutions, big people who already have publicity. So if you are already a very prominent scientist, everybody will care even for small things. Okay. But if you're building a story, typically the first 4 are quite important. Okay. So also what other things make news? It's novelty, something innovative. okay, such as it says here, the first landing. Somebody that's personal and has some human interest, somebody got hurt, somebody got in a very unusual situation. Conflict, war, always makes the news, war, okay? Even if it's a very hot debate. Yesterday, I was reading something on climate change in Καθημερινή, which is a newspaper of very wide circulation in Greece, and it was talking about climate change, but it started as this, taking initiative from the recent fires in California. Okay, yes, because if it spoke about climate change, everybody knows, okay, we got bored. For the journalist, this is the way it is. Okay, even if it's in your very important field of research, you know, the journals, the newspapers start getting bored. But now that we have the fires in California, okay, this is a good hook. So initiating from this, I will take you to another point. Okay, this is a nice hook. So conflict, disaster, this already makes a lot of information. If you have exclusivity, so we only have this news, a scoop, the gossip that was mentioned earlier, this is also very important, and currency. So it's, as I said, okay, look, California fires, and I can tell you this about climate change. Now, typically what we want to do, and maybe this was mentioned by other speakers in previous talks on how to write a paper, you want to build a narrative, okay? So what a narrative means is making this very interesting, making your piece not being about something that's soulless and heartless, give it some kind of importance. And this importance could also be some form that is more human-like. So, for example, a narrative could involve a protagonist, which could be the phytoplankton. Okay, so suddenly we start caring about the phytoplankton. Oh, what does it do? It doesn't sleep. It migrates. Okay, so you're giving it a very somewhat bigger importance than it has, and this protagonist goes through obstacles, another obstacle, and then it reaches its goal. And on this story, as it progresses, you also start learning some facts, and you also start learning and becoming transformed yourself. Okay, so you need to establish a story behind your communication there. And there are different types of narratives that you could choose. For example, you can have the narrative of a quest, sort of like the Jason and the Argonauts or the Ulysse, Odyssea, okay, where the protagonist can be the scientist. This is also important. So we were looking, and then we found this, okay? So this can make your story a bit important, a bit interesting to read, I would say, not important, interesting to read. Another narrative you can choose to go with is from rags to riches. We always thought that this is not very important, but our work highlights how it is, okay? So if you have a protagonist that's the poor worm that nobody cares about, and we might be stepping on it, and we might be stepping on ants, etc., but this organism plays a very, very important role, let's say, in biodiversity or in circulating nutrients or in other aspects. So give a story to the reader so you can draw them in what you're trying to explain to them. Okay, and another narrative could be a mystery. So who did it? Who was the culprit? Who had all this? Who made all this impact that we're seeing around us? Is it this poor electron? Is it something else? Like, what was the cause of this huge measurement that I made? And also, it could be the scientists who play the role of Detective Poirot or whatever. So anybody who has a question can interrupt me in the meanwhile. I think that we are right now, cannot clearly see also my slides here, but we are 10 or 15 slides from the end of the presentation, which is okay with time as well. So a few words about structuring longer articles. Okay, as we said, there is this inverted pyramid, where first you have the lead, or otherwise we call it the hook, what draws the client in, let's say. Okay, and then you go in details, and then you go in context. And these two parts for me, 1 and 2, hook and billboard, are the most important. So the first part is the hook. The second part is billboard, or a nutshell paragraph, or the paragraph that explains the rest of the story. I would say that the hook can be something like 30, 40 words, okay? No longer than 3 lines of your text, 1 sentence. If you don't make it there, nobody will make it later than that, okay? And then once you draw somebody in, you sort of explain a bit more about what happened. So you explain in a nutshell, in a short paragraph. This could be 100 words, 120 words, an extra 5, 6, 7 lines, 3 sentences, let's say, 4 sentences of your text. Explain in a nutshell what you're talking about. Okay, then the next paragraphs can be the background, can be quotes, can be how different scientists comment on this finding, how you did it, what the methods were, okay, what the conclusions, the outlook are, okay, and the outlook is in this line of work called the kicker. And I would also add here that, okay, at this point, once you mention the outlook, you can also mention who funded this research, who else participated, and so on and so forth, depending on how much space you have there. I think you should, in the press release, you should definitely have these points, okay, at least acknowledging your co-workers and the funding. Okay, so let's stick to one, the hook. Okay, what can make good hook? It's one of the ways to do it is that you drop, let's say, a character in the middle of the action. So you pretend there is a scene, and the scientists fall into the jungle and start observing the animal. Or you pretend you're, again, a scientist and fall into the phytoplankton and start observing what's going on, okay? You might have a fascinating historical anecdote, okay? In the 21st century, 18th century, this is how they did it. Or this is the first time somebody invented something. And then from there on, the evolution came and we found this, or we found that this is not the way it works, okay? You could start speaking about climate change. My very typical entry line, let's say, when I start speaking about climate change, is that all this is very well known since Arrhenius, or that all this is very well known since the Clausius-Clapeyron equation, okay? This is not new. This is well known, so here are the facts. You can have an illustrative case study, an illustrative example, okay, that people can relate to. You have a fieldwork location. So, okay, scientists in Hawaii, they're digging up a hole. Okay, I will tell you what they're doing, because people might get curious about what is a guy in the North Pole doing, digging with his little shovel a hole. It's like, what are they doing there? Especially if they are from Greece. Okay, that makes headlines. Huh? A mystery, a puzzle, and a tricky question. Do you know that XYZ? Okay. I wouldn't use this as a headline. Okay, there is a famous quote from Umberto Eco that says that if there is a headline that has a question, typically the answer is no. But okay, still, this can be something of a clickbait. Huh? It could be something that is dazzling, a big number. Okay, you know, 1 billion things happen, or Bitcoin has the power to move mountains because it's they have raised millions for this coin. Okay, and maybe little known facts. You didn't know that the phytoplankton could do this, did you? So these are the good practices you can follow, but this is not always the case. There are also many times, and I'm pretty sure that you have come across it, especially if you are sometimes reading a special kind of press, like what I can say, the Daily Mail, let's say. Huh? So if you come across this type of news outlets that typically look for clickbait and typically have big headlines that mean nothing, you have surely come across this. Yes, it's from the Daily Mail. Okay, do not try to exaggerate too much. For example, look at this headline: "Are smartphones making us stupid?" Okay, so yes, it is something that you want to go look into because everybody has a smartphone. Okay, so this affects you for sure. And are they making me stupid? I want to know. As I said, Umberto Eco said, if there's a question mark, the answer is no. Okay, so Googling information is making us mentally lazy, study claims, and then they drill down. And I'm pretty sure that in this story, the conclusion is that, okay, this is not the way it is. Here's another one, exaggerating a bit. The scientists to trial new cowpox-style virus that killed cancers in lab tests on humans. So yes, this is somebody that affects everybody. They found the cure for cancer. This is what these guys are saying. Okay, so this affects everybody because, okay, this is what humanity has been after for the past, I don't know, 50 years in terms of in medical science. And then you read on and you read on and you read on, and actually on the last line of this article, it says cancer cells are easier to kill when they are in a dish or in animals with impaired immune systems. So these guys never, ever tested in humans. And it's not the problem of the scientist. I'm pretty sure that if I look this article up, it will say we tested in mice or we tested in Petri dish. But how this was picked up by the actual press actually twists around on the story science side. Okay. Now there is another study that famously went very, very wrong. Okay, there was an article in Letters to Nature, so yeah, it's quite it received quite a big exposure, and there it said that the scientists predict that on the basis of mid-range climate warming scenarios for 2050, so an average climate change scenario, you might know that there are several socioeconomic scenarios that lead to different global warmings. So on an average one, not a very extreme, it says 15 to 37% of species in our sample region. Okay, so in an area where they sampled some species, 15 to 37% of them are committed to extinction. Committed to extinction. They're not actually extinct. They're committed to become extinct in the future, not by 2050. Okay, so they specified that the proportion of the species that they studied as of after 2050 will eventually become extinct because there is a bottleneck, for example, from evolution. Okay, so this is what these guys said in this article in Nature. Okay, so what happened? So there's a press release from Nature and says, author et al. Now show that the global warming could wipe out 15 to 37% of a sample of 1,000 land plants and animals by 2050. So the first problem was in Nature Press. Okay, Nature Press said that 15 to 37%, well, okay, they said from the sample, but they said that by 2050 they will be extinct, which is not what the actual paper said. Okay, and then from the University of Leeds, which was the institute of the lead author, let's say, they also made the press release. And they projected on that number and said, if the projection can be extrapolated globally, so they took a sample of 1,000 species, out of this 15 to 37% would be extinct. And they say, okay, let's take it and stretch it to the limits, let's project it. And if we say, if they get extrapolated globally, to other groups, so not to those studied, and I think that these authors studied butterflies, so okay, this is too much. Our analysis suggests that well over 1 million species could be threatened. Okay, so it continues to get pulled. And then, okay, they release a statement. I mean, everybody saw it and said, okay, something is wrong with it. And then University of Leeds corrects this, and it says, however, okay, so these forecasts are for species predicted to go extinct eventually based on climate change that will occur between now and 2050, but eventually, not until 2050, they corrected it. However, as some species respond slowly to environmental change, they will not all go extinct. Okay, so yeah, what we studied was actually more, let's say, species that are more sensitive to climate change, to environmental changes, and they will go extinct, but not everybody. But in the meanwhile, this press release was got by the press, and it got even worse because Reuters, it says global warming could wipe out a quarter of all species, okay, of plants and animals on Earth by 2050. That's a very, very bad prediction. Okay, now we can laugh about it because it's already 2025, and this is in 25 years. But when this was first released 25 years ago, it said in 50 years, a quarter of you will be dead. So that makes headlines for sure, but it's not really the case. So it can end up pretty bad. Okay, and this continued because after Reuters got it, The Guardian got it and said 1 in 10 animals and plants are going to be extinct by 2050. Okay, and these are the cuttings from the papers. It says extinction cascade may decimate world biodiversity by 2050. Even worse, 1 million species will be lost by 2050, 1/3 of the life forms. Okay, this is completely nuts. Yes, they earned, these guys, they earned a lot of, let's say, headlights, but not for the right reason. And it ended up, let's say, as a gospel, okay, and it got into the European Parliament as well. So, as I said, your audience eventually can be policymakers who want to use these arguments. And okay, once this reaches that state, somebody could pick up the phone and say, and unfortunately, this has happened to me as well. Somebody who gets offended by how this thing propagates picks up the phone and says, your research is rubbish. Okay, so you definitely don't want to end up there. Okay, because you will have a lot of explaining to do, or anybody, the people who transmitted it in this direction, in this way, will have a lot of explaining to do. So what happened? Actually, there was a publication that used this publication okay, as a basis, and they also searched other how this publication propagated, and it said that out of 29 UK newspapers, newspaper articles, 20, so 2/3, were erroneous, and they said they had errors, and they predicted the extinction of 1 million species by 2050. So the initial press release made many bite in this wrong argument. Only 2 reports explained that, okay, guys, this was a sample of very few, let's say, species if you compare it to the global population. So we don't know exactly what's going on. This cannot be projected to the rest. And 2 reports suggested that 1/3 of the world's species would go extinct. That's pretty grave. Okay, so going back to best practices, you want to be credible. So you want to eliminate all these possibilities that what you say can be misunderstood. You want to be 100% clear and simple. Okay, and you want to be accurate. You don't want to exaggerate. You don't want to be perceived as a liar. You don't want to be perceived as one who, exaggerates his work for funding, let's say, or to draw attention. Okay, this is also a big conversation in climate change research and climate change communication. And also there is a big debate about if climate change scientists should downplay the research. Okay, and this is a big conversation as well, that a lot of impact studies have been downplayed, even though scientists see that the impact of climate change will be bigger. They say, okay, let's not say too much, because if it doesn't turn out the way we predicted, then we might be considered to be inaccurate or incredible. Okay, so one way that you can never go wrong regarding numbers is that you should report absolute risk with relative risk. This means the following. So let's say you have a hypothetical example where a relative risk says that using a Bluetooth headset could double the risk of brain cancer. But if this risk is 0.00001% and you double it to 0.0002%, it might not be significant to the reader. Okay, so always convey this. It would definitely make headlines if you say double, but always explain what you mean by this. Okay, what other problems you can have? You can use inappropriate language. You could use language that's not gender neutral. Use language that could offend in some way, socially or in other ways, your readers. Okay, so try to fully avoid this. And always avoid something that's called defamation. So be objective about the things that are in your science field. Nobody wants to point fingers and say, okay, this authority did something wrong. This other researcher did something wrong. They did not calculate the facts as they should. I am better than them. Okay, stick to what you are doing. Don't compare yourself with anybody else. Pat in the back the people around you or the services that provide the data. Don't point fingers when it's not required, because if this happens in certain countries, there are libel laws, which means that if somebody thinks that they get defamed, they can make a defamation lawsuit and pursue it for damages. So always take care about this. What other problems you could have? You could mess up with copyright law. So similar to your papers, everything there should be yours. Everything there should not be plagiarized. If you copy things from other authors, you should clearly stated, or you should clearly get permissions. If you get some quotes from other blogs, you can link them, you can link other work, you can also make use of copyright-free material, okay? And if you have questions, you can always check with the staff of your university, of your institute, or your colleagues who know better about this information and can cover you with licenses or can cover you with their permissions, etc. Okay, you can get images from various sources if you want to use something. Something I forgot to say, sorry to roll back here. Something that I forgot to say is that here in this example that we had in phytoplankton, as I said, here the authors had several figures in their paper that were very complicated and very difficult to understand, even for scientists. So there was absolute no point in publishing these in a newspaper, because they would need an extra 2 pages to explain what this is and how this works and why this plot and this trend actually proves what they're saying. Okay, so there's no need to go into this detail. How this propagated in the press release is this image of a phytoplankton cell. Okay, so something that's very nice to look at, let's say, a detail of your work that otherwise on a science forum, it would not be important, but as art, it could be nice, or highlight something that people don't see very often, a detail of nature that's hidden to them. Okay, so even, for example, this image shows, something that speaks better to the average Joe than a diagram. Okay, unless it's financial information about costs, let's say, don't put it out there. Make something simple. Okay, I think that the most high-level information that people can process are the meteorological forecasts. Okay, there they could understand. Financial forecasts, financial figures, diagrams, etc. There they could understand. Okay, go into publications, news outlets such as Economist and Newsweek to see what type of figures they make and how they structure the axes in their plots, how they structure the lines in their plots, and there you will see what type of information people can consume very, very easily. So the best way is to create your own. Have your own microscope, take your own picture, have your own nice camera, take your own picture from the field. And this is the best to put in your work. If you cannot find this easily, you can buy pictures from several outlets such as iStock Photo and Vato Shutterstock. You can ask for permission if there's a copyright holder. I've sent hundreds of emails to people asking them for permission to use their images. And typically people don't care unless if they're professional photographers, and they will say, okay, yeah, okay, write my name under it. Nobody is so hard on this unless if you take it for granted that they will and you use it without their permission. Okay, and there is also copyright-free material that's under Creative Commons, and there are some tools in Google Images and also in Flickr where you can have a drop down, let's say here, and this is in Flickr, you say, okay, I want to select only images with Creative Commons licenses. Google has a similar tool, and then you see what's, let's say, free to use. You can also typically go in Wikipedia, and there the images are Creative Commons, so you can use that as well. And always closing up and wrapping up everything, always acknowledge your funding. I should acknowledge the European Union, which co-funds Impact here. And, ask the funding authority about what the right way to acknowledge them is in this work, especially if it's part of your deliverables. Acknowledge your sources. Okay, here I've taken many parts from a book called Science Communication, a practical guide for scientists, as well as a storytelling seminar that was in the Coast Academy. So Coast is probably you've heard of it, is an instrument of the European Union similar to Horizon. And there was a seminar for science communication coordinators. And also, if you want to read further, I have provided some links from YouTube and some reading material. And I think that concludes my presentation. So, dear colleagues, questions? Okay, there is one from Ivan. Or Ivan, I don't know if I'm pronouncing it right. Ivan, you can unmute yourself and...
No, sorry, it was just a reaction.
Okay, so that's fine. Any other questions from the audience? Okay, for you who want to receive credits for this course, I am putting out some assignments. So right now, if you look at the Moodle, there is one writing exercise, but I think during the day, or actually it's getting during the evening, I will probably include some other quizzes, etc. for this. And as always, I can accept emails or calls if you have questions. Too much silence. Okay, so I think this concludes our course for this evening, and I will see you in the next one. Okay. Have a good night, everybody.
Thank you. Have a nice...
Καλό βράδυ. Good night.
Καλό βράδυ.